Indexing. Very important. Each of the elements of a matrix has its number or an index. And those indices can be encoded in two different ways. First, you can type just one of few numbers in the parentheses after the name of the variable. This will call or select a certain element of the matrix. How do we know which one of them is the first, which one is the second? There is a rule. So this one is first, this one is second. Oh, looks bizarre. This is the third. Here goes the fourth, and so on and so forth. So first you count down in the first dimension, which is column, according to this law, and then when the column is over, you switch to other column at the top, and you repeat. So if you call first element, it will give you this one. If you call third element, it will give you this one. You can type, as I told you, a number of elements. In fact, this one, it's a matrix. It's an array. And here you have a number of elements from 1 to 6. The outcome should be precisely those 6 elements. First, second, third, fourth, fifth, and sixth. You see, they are ordered differently. Now it is a line, it is an array. But they are all taken from this original matrix. The other way to index is to indicate sort of coordinates. As we have 2 dimensions, we can type 2 numbers which will indicate which row and which column should we take. And in the intersection of a row and a column, we will get our value. So if it is third row, 1, 2, 3, third row, this is our third row. And second column, this is our second column. So the intersection is this one, this 7. There is a mnemonics to remember the order. Mr. Nice Guy. M stands for rows and N stands for columns. So if you type something like this, you will get 7. This element. Or you can type just 6. So this. If you don't use comma, see, the comma, it separates 2 coordinates. If there is no comma, if there are brackets, then it will take the third and the second. The order of the elements that we call can be any, and you can call as many times as you want. So you can call, for example, 3 times the same element. This is totally accepted by the logic of MATLAB. This is indexing. Now we should try those expressions. Looks okay. Let's remind ourselves what is A3. Just type A3. So those are our elements of A3. The first element is obviously 2.5. Let's take the fifth element. The fifth element, if we count according to this rule, will be 3. 1, 2, 3, 4, 5. The value is 3. If we take 7, it will be 4.8. And if we take 9, it will be 8. Instead of 9, you can also use operator AND. It will give you the last element, whatever is the element. Depends on the size of the matrix. Obviously, there is an error here. Let's copy this. Works fine. We can try to change the order of those elements. Any order. And we can take the same element many times, like the second element. Anyway, it works well. And this expression is also very important. Now, give us 7. Let's again call A3. So, third, remember Mr. Nice Guy. First row, then column. Third row, second column. We can try a different combination, like third row, third column. It will give us 8. This element, or first row, third column, it will be 4.8. Also, you can take a number of columns given the same row. First row, and first, second and third column. It will give you this. You can use two matrices, two arrays for indices, and not necessary in the right order. So it can be second, first, third, and here it can be also different order, like third, first, second. Let's now try to predict what do we get. However, it is quite easy to find out how does it work, because everything is quite logical in MATLAB and pretty intuitive. So let me explain you why do we get this kind of matrix after this kind of coordinates here. When we indicate second row, the program first goes to second row, which is this. But then it is going to execute all the three indices in respective order for the columns. So first it will give you the element number 3 of this row, 4. Then it is going to give you first element, which is 2, 2. Then it will be second, 3, 3. Then, as soon as those are over, it will examine row number 1. So this is row number 1. And now the order is going to be the same. First, the third element, which is this one. Then the first. This goes for the first. This is the third element of this row. Then you seek the first element of this row, 2.5. Here you get 2.5. Then you go for second element of this row, 3.7, 3.7. And next you go to the third row. And again, first the last third element, 8, 8. Then the first, 3, 3. And last, the second, 7, 7. While what we predicted for 2.5 and 7 are located exactly on the diagonal of the matrix. I don't think that this kind of problem is something that you are going to face often, but this one is quite likely to be useful in your data operations. Why would it be in general so important to bother indexing? At the first sight, it looks like just some playing with numbers. On the contrary, it is an extremely important option of manipulating data, because if you come to see this teaching course, you are most likely interested in some kind of experimentation with humans, studying psychophysics or behavior or neuroscience. If you do experiments, you get data. If you get data, typically you don't need data just to have it. You will likely want to analyze the data, and analysis of the data is overwhelming majority of the cases a comparison between something and something. Therefore, first you split your data into some parts, and then you compare those parts, like one condition against the other condition, one group against the other group, one time against the other time, one region against the other region, one drug against other drug or no drug. There's so many ways to analyze the data. But anyway, you have to select elements of your data table, of your data array, and extract them into different variables, different subsets of the data. And this is where indexing is absolutely invaluable. Therefore, I recommend you strongly to focus your attention on this topic. Perhaps it is the most important part of what we discuss here today. So this is what can be done with the operator of colon. Colon in simple language will mean all. If you type something like this, it will be first row, all columns, this piece of data, and you get this kind of response. By the way, pay attention that here A3 is again without underscore. Sorry for those inaccuracies in my presentation, but they can be sort of interesting for you, since you will have to pay attention if you write your variables correctly. Those are called bugs. So this is another awful error. It's just a typo. Let me correct it. So this will give you one column and all rows. Let's try it. And other way around. Yeah. See, the 9 is here. And we take all the columns of all the rows of the third column. This is third column. Those are all the rows. Of A3. So let us remind what is A3. This is A3. Then we have now both A3 written like this and A3 written like this. So now we are safe. Anyway, third column, this is not this variable. Now we use A9 for a new purpose. So here A9 was something like this. Now we use the same name to extract something from A3, and it gives us something totally different. So we reuse the same name of the variable because we lose what has been there previously. So now we deal with A3 and we select the third column and all the rows. We will typically pick those elements, and those are here. Let's try something else. First column. This is first column. All the rows. Now we can try second row and all the columns. This is what we get. So if A3 is like this, we get.
Папа, мы поели. Мы получили печеньки. Мы поели.
Sorry for this interruption. other option is of indexing is to indicate the range of rows and columns. So this expression means that you take from first to second row, first to second, and from second to third column, second to third column. 2 rows, 2 columns, and it gives you 2 by 2 matrix. Let's try this in MATLAB. Yeah, we get exactly what is expected. Well, if we take from second to third row, we will get this 3, 4, 7, 8. 3, 4, 7, 8. With the help of the column operator, you can generate an array. This expression means that you create a row of data starting from 1, ending with 5, and with a step of 1. And here is the newly generated data array. You can indicate a step of 2 by separating it from the beginning and the end value, and each new element will be greater by 2 from the previous one. Let's try this. Works. Also works. The step can be any value. Instead of using numbers, obviously integer numbers, 1, 2, 3, there cannot be such an index as 2.5 or 3.7. You can also use logical matrices for indexing, for selection of a subset of an array. Let's consider this array that we have just generated and use a logical expression to identify those elements which are greater than 4. There will be 3 elements where this expression is true, and this is a new variable which is an array of logical elements. Now we can put this variable in the parentheses after this variable, and it will select those elements of this variable which are true. Those 3 at the end. Alternatively, you can directly place this kind of logical expression in the parentheses. Therefore, you skip this step. I often do something like this, but it makes expression more complicated for understanding. Anyway, the outcome is this one. We copy this expression to command window, and we get exactly what is expected. Let's change it. Let's select everything that's smaller than 4. And now if I remember well, we created another variable and we put A10 in parentheses after variable A9 in order to select those elements which are logically true. It is important that the number of elements must be the same here and here. Obviously, in case of this expression, it cannot be different. But if you generate it in an alternative way, and the number of elements of the indexing matrix is different than the number of elements of the indexed matrix, MATLAB is going to give you an error message. So A10 is logical, 5 element, and in this expression we will have this outcome, 1 and 3, 2 elements only. Good. Now we can go to the next section, which is slightly simpler and not that critical, but still it's worth keeping in mind that you have not only numerical values which can form your data. You might have also text variables or strings. Symbol for string variables is this one, and you can create string with the help of those apostrophes, double apostrophes at the beginning and at the end of the string. Importantly, string can contain any kind of characters, including numbers. So if you type here 10, it will still be a string because there are apostrophes. If you remove apostrophes, it will give you a numerical matrix. They look the same, but they're totally different by nature. You can do different mathematical operations with numericals, but you can do absolutely no mathematics on text characters, except counting some occurrences of the elements in the text. However, potentially, if you do sophisticated analysis of the text, you might be able to extract numericals from the text, and then those numericals converted into proper format can be used for mathematical computations and all sorts of data analysis. However, despite you cannot do mathematics, you can easily do logicals. For example, you can find the elements of the array 12 which are equal to I. There are two elements here. Spaces are also elements in this case. Letters, spaces, any kind of symbols, all of those are elements of an array. So we can rerun this operation. We create A12, which is a string 1 to 24. It's a long string, a lot of letters and symbols. And now we paste this expression that gives us another array which is logical, and the size is also 24. However, only two elements, the fourth, this is the fourth element, which is I, and I don't know, more advanced score for another I which occurs in this text. This is how logic works in MATLAB. If you don't want to count manually, you can use a beautiful function which is called find. This function will find all true elements indices and give you in a shape of another array. So now you know that it is 4th and 11th element, and you don't need to count. Isn't it beautiful?